Dear students, you see, uh, you have to just give you certain tips how we will to attempt the problem chapters of the electrical installation and estimating. And here is a problem. I am to say how to how to appear the problems in the electrical installation and estimating in the examination hall, and here is a sequences on which we proceed in the examination hall. Here we can say that in the basic upon the problems we will face the step 1 assumption. Assumption means which is not given in the question. Suppose the height of the building you can take that is 3.5 meter, and the you can take how much what is the floor distance to the switchboard distance, and from switchboard to the horizontal run. Horizontal run means on certain distance from the roof we can give the horizontal pipe connection, that is called as the horizontal run. So these are the assumptions we will take, and first step we have to take the assumptions, and the second step is the installation plan. So for an example, we have given in the question a room of size, room and a veranda having size 25 meter square. So you see that here is a room and here is a veranda. So it consists less than the 25 meter square. So how we will equip the bulbs, switchboard, and that is the energy meter and the main switch, like that. In that way, as per the guidelines of the that is Indian Standard Electric Rules, we will draw a plan, and that plan is known as installation plan. You see that here you have taken a tube light at here, a fan at here, a light point at here, a switchboard, and the both sides in the inside the room and outside the room, which is known as veranda. Here is the main switch, here is the energy meter, like that. And here the outside to the point we have taken a light point. So how the points are installed in a building, that is known as installation plan. You see that this is the installation plan, and after that installation plan we will move to the step 3, the connector load in amperes. So from this installation plan we will see or calculate the connector load in amperes. Amperes means what is the supply voltage to be given to this connection circuit, and what is the total wattage connector load to the room. So total connector load in watts and total supply voltage will get the ampere, that is watt by voltage. That is, you see that watt, that is nothing but V into I into suppose unit power factor, and suppose the supply voltage V. So V can be cancelled out, and we will get the only the current in amperes. So by this way we can calculate the total connector load in amperes. So that as per that connector load in amperes, we will have to select the main distribution board, or that is called as main switch and main distribution board, main switch and the main distribution board. Suppose we will calculate, suppose it is the total connector load in amperes, it is suppose 22 ampere. We say that is 22 ampere, but that amperage, in that amperage the equipment is not available in the market. The nearest to that amperage which is available in the market, suppose that is 32 ampere. So we will select that 32 ampere of the main switch for this wiring purpose. So depending upon the connected load in amperes, we will select the main switch and the distribution board like that. So that is the step 4 for the main distribution, selection of the main distribution board. And step 5, that is calculation of conduit pipe. So if we take the wiring for the casing capping, or the that is a lead sheath wiring, or the that is conduit wiring. So conduit, again it is divided into concealed type of wiring or surface wiring. So by that way, what type of wiring we will select, or in the given in the problem, we will have to calculate in that way. Suppose we will select or we will choose for the surface conduit wiring. So for surface conduit wiring, we will have to choose the calculation for the conduit pipe. In the next diagram, that is called as a isometric view of the room. Isometric view of the room means so in this type of diagram, we can able to see that means it is some inclination to the ground. If we draw a diagram, the picture will be like this. So in this diagram, here we have taken, this is the main switch. So this is the energy meter, this is the main switch, and this is the switchboard in the both sides, and here is the door. And as per this installation plan, we have taken the light 1, light 2, light 3, and tube light, and the fan. So as the height of the total roof from the floor to the roof is 3.5 meter, and that the split up of the 3.5 meter is like this. Will take up to 1.5 meter. Will install the switchboard, and from switchboard to 1.5 to the towards the roof, we will take the conduit or the position of the light point, and from 1 point to 1.5 to roof, it is 0.5 meter. So by this way, we will have 3.5 meter. So this is a split up of the height of the floor to the roof. By this way, that is 1 point from the ground, it is 1.5 meter. The situation or the installation of the switchboard, and from switchboard to the conduit pipe, it is 1.5 meter, and then from the onwards to the roof, it is 0.5 meter. So by this way, it is 3.5 meter. And if we calculate the next sequence is for the calculation of the phase wire and neutral wire. So as it is a tube light, it is a fan, it is a light point. So for this tube light, 2 wires are there, one phase wire and the return path is a neutral wire. So similarly, here is the light point, here is a phase wire and the neutral wire. So for the fan, it is a phase wire and neutral wire. So by this way, here is the four wires, the two wires. The wires, the specification is as per the connected load in amperes. So up to that size of the wires, it is 4 number wires up to this length, that is 4 meter. It is up to 2 meter. By this way, we can calculate all the wires used in the wiring purposes, considering all the points, tube light point, fan point, and the switch point to the energy meter point. We will have to, in every step, we will calculate the length of the conductor for the phase wire and the neutral wire. And the next step is for finding out the length of the earth wire. How earth wire, running earth should be given to the plug point for the safety point of view. So that earth wire, length of the earth wire should be measured and that should be calculated. The next step is for calculation of the for the wiring diagram. How the wiring diagram can be drawn from this isometric view. In the next page we'll see. The next diagram showing the wiring diagram. Wiring diagram is first the supply given to the energy meter, from energy meter to the DPI switch, double pole ironclad main switch. As per the selection of considering the amperes, then from the main switch it is coming to the first main switch board. First main switch board is the dotted line is the earth wire and the board line is the phase wire. So all the switches they are connected with the phase to the load circuit L1 and L2, and all the socket points they are earthed by the dotted lines. So by this way, this is switchboard 1, switchboard 2, and with this we have connected the light load, light point 1, light point 2, light point 3. This is a fan, this is a tube light. So this consists of wiring diagram totally for the installation plan, as per the installation plan. So after that we have to the last step is for the preparation of the material table. So material table means what type of materials is used, like that is a energy meter, the DPI switch, the switches, the conduit pipe, the light, the number of the lights of which wattage, and the fan of which type, and tube light is of what type, and all that things are included in the list, and that is called as a material table. So this consists all about the sequences to be carried out during solving the estimating in the electrical installation estimating. So if I think that if we follow by this way, I hope you all success in the examination and you will never be detract from the steps, and you will success in your you must appear that problem, and also you must be successful in the examination. Thank you.